Angle of elevation and depression, application of special triangles. Well, in this series we're trying to understand what is angle of elevation, what is angle of depression, and how special triangles help us solve practical problems, correct? These problems are very practical, and that is how the height of trees, mountains, and things have been measured in past. Well, question 3 says, to find the height of a tree, a person conducts measurements standing 55 meters from the base of the tree. If the angle of elevation to the top of the tree is 60 degrees from a point 1.2 meters above the ground, find the height of the tree. So let's first visualize it. Let's say this is the ground, and here is a person standing, correct, and doing some measurements at this level. So that's the level from which the angles are being measured. And here we have a tree, right? Let's say this is my tree, and well, let me make something green here to show that, well, that's a tree, right? Right, okay, that's fine. Now that's the huge tree, okay, that's fine. Now the measurements are being done from this angle, and says, well, the distance of the person from the tree is 55 meters. So this is 55 meters for us, and the angle is to the top of the tree. Let's make this angle to the top of the tree and now figure out what we have. So what we have here is, to find the height of a tree, a person conducts measurements standing 55 meters from the base of the tree. If the angle of elevation to the top is 60 degrees, so let's make this 60 degrees, from a point 1.2 meters. So this point, this height is 1.2, so this also becomes 1.2 here, right? Above the ground, find the height of the tree. So we have to find this height, this total height, correct? Total height. That is the problem, correct? So you see, there is a person standing 55 meters away from the tree, and that's the measurement. So probably the eye level is at 1.2 meters above the ground, and from their angle of elevation. Angle of elevation is the angle which we see with the horizontal, always with the horizontal, right? So when you see in this direction, that's the ray, and from here with the horizontal, it makes an angle of 60 degrees. Now since we have 60 degrees here, let's draw our 60 degrees triangle also, and we'll make this 60 degrees triangle and write down for 60 degrees triangle what do we have. The sides are 2, 1 and square root of 3. So that is our 60 degrees triangle. So that is what we have, and this is going to help us solve this practical problem, correct? Now let's say that this distance from here to here is, let's say, y, from here to here, correct? Now if we consider that this small triangle here, in that case, let me label it. Let's say this triangle is ABC. Okay, let's say ABC, right? D and E may be these points, correct? These are also important for us. So let's consider the triangle ABC. So we're considering the triangle ABC, and in this triangle, what is sine? Okay, what do we know? We know two things. One is we know the distance between A and C, because that is going to be equals to 55, same as this. And we know the angle. And what we need to find is the opposite side. So when we need to find opposite side and we know adjacent, the trig ratio, the trigonometric ratio, which relates opposite with adjacent, is tan. And therefore, we can write tan of 60 degrees is actually equals to y over, let me write first BC, this height, over AC, the distance between them. And BC, we don't know. Let's write down a variable y for it, and AC is same as the distance from the tree, horizontal distance, which is 55. Now, so here we have one variable y which we can find. We know tan 60 from a standard triangle. Tan 60 is square root of 3. So we have square root of 3 equals to y over 55. Perfect. Now therefore y is equals to 55 times square root of 3. So we can use our calculator and figure out what is this. So square root of 3 is equals to this, and then multiplied by 55 will give us a value which is 95.26. So this is equal to 95.26. Okay, so let's say 95.3 meters. Okay, so that is the height of this. Now I rounded to 1 decimal place because the other number here is 1 decimal place, correct? So the total height of the tree, which is h, is actually equals to 1.2 plus y, correct? Is 1.2 plus y. So I could write this as 1.2 plus 95.3, and that gives me 0.5, and on this side 96. So it is 96.5, and the units are meters. So that is the height of the tree. See how easily we could do this problem by knowing our special triangles, correct? So that answer is to 1 decimal place. Sometimes in the questions they will say round your answer to 10th of a place or 100th of a place or to a whole number. So depending on that, you should do that rounding. At times they may also ask you exact answer. In that case, we don't have to solve this. I mean, write like in decimals. 55 square root 3 is your answer plus 1.2, correct? But in this kind of a problem, since the height is given in decimals, it is preferred to calculate and write your answer in 1 decimal place, right? So what you take from this question is, first, always in a given situation like this, try to sketch, label your diagrams, write down what all is given, and give name to the variable for things to be found. So we wanted to find the height of the tree from the ground, so that be h. And then we found out there's another variable to be defined, and we utilized our right triangle ABC to figure out that height. And finally, total height was that height plus 1.2, the eye level, okay, and got our answer. At times I have seen, students somehow miss that adding 1.2, and that results into huge loss in marks. So be careful while doing these problems. Okay, take your time, try to understand the question, and then do it as shown here. Thank you.